A standard instrument on board most oceanographic vessels is a CTD rosette. This has computer-activated bottles to sample ocean water at predetermined depths, as well as a CTD instrument to measure conductivity, temperature and depth. While on station for mooring operations and also at predetermined way sites, this instrument is deployed. Ocean water is then analysed and the data shared, for most part globally, via atlases, compendiums and annual ocean reports. The K-12 summer school participants had a unique opportunity to learn about the Arctic from leading scientists and educators in a wide spectrum of polar and Earth system science disciplines, from meteorology, biology, chemistry and oceanography, and to experience Arctic research by observation and participation in some of the high-latitude Arctic climate change research under the guidance of experienced polar researchers. Let's listen in on some of the lectures for the summer school participants.
The new IceSat has a laser altimeter so they can get the freeboard of the ice. Then the main components of that are a thermistor string and some acoustic sounders, which I'll go into a little bit. We've had many different modes of how to get things up in the air. If you go back to basics, it seems to work the best. We freeze a PVC pipe into the ice. This is an acoustic air temperature sensor. We call it 2 meters, but we don't measure it to be 2 meters, but a standard height is 2 meters. We want to get it up above the blowing snow and up in the air so there's less rhyming because the ice builds up on everything. People have problems with anemometers because they always frost up and then they stop working. So we just tried to get it up in the air, and it's just a simple, it's good to a tenth of a degree.
This is the hydrogen. I tell my kids it's hydrogen hands, okay? So these are the hydrogen hands. What are they? What are they? What are they? They're kinda, no, they're kinda what? Positive or negative? Positive. Positive. How are you gonna remember that? Okay, think of what's at the end of cats or polar bears. What are these? They're paws. Because the fact of the matter is that water-specific heat dust is so strong and it's such a great absorber of energy that it will actually prevent this balloon from blowing up.
The Kapitan Dranitsyn is a powerful, conventional propelled icebreaker constructed in 1982 at the Wärtsilä shipyard in Helsinki, Finland. Its 6 diesel engines produce around 25,000 horsepower. The bow and the hull of the ship are specially designed so that the ship actually breaks ice by sliding up on the shelf, and then the weight of the ship fractures the ice sheet. The Kapitan Dranitsyn can break ice up to 2 meters thick, but it is most efficient in breaking 1 meter thick ice, which it can sustain at around 7 knots. The Kapitan Dranitsyn has comfortable cabins, lounges, a library, an auditorium, and laboratory space for up to 70 scientists and embarked personnel. The ship is owned by the Russian Federation and operated by the Murmansk Shipping Company.
Похоже, что она на дне. Attention, please. 3 polar bears on the starboard side. 3 polar bears on the starboard side.
One of the highlights of the 2006 NABOS cruise was the rendezvous with the French yacht Tara. This vessel is attached to an ice floe and will drift with it for 2 years. Crew changes are scheduled every 6 months. The Tara has an interesting history. Originally owned by well-known yachting personality Peter Blake, who was killed by pirates in the Amazon River. The Tara is not ice-strengthened, and this is why the Kapitan Dranitsyn was mission critical for it to get to the ice floe. With only a thin aluminum hull, the Kapitan Dranitsyn was essential for breaking ice for the Tara. In fact, the Kapitan Dranitsyn mission was changed to accommodate the Tara's late departure from the Russian port of Tiksi. Let's now listen to some of the live commentary. Down on the helo deck now is Jean-Claude Gascard, the head of the Damocles Tara group, and Jean, one of his team. You can see some snowflakes blowing around. That's sort of everyday occurrence here. There's a marker in the ice that we're looking at now. This was the floe that was selected overnight for this rendezvous. So this is where, roughly where they think they'll make the transfer of the kerosene and other provisions. And that was marked out apparently last night. But they're so far behind that the breaker, the icebreaker, that the ice is sort of regrouping. And I'll show you in a